Dr. Alistair Carr got his PhD in 1999. Since then, he's worked as a research scientist at Fonterra for 10 years, and he is now a senior lecturer in food technology at Massey University, specialising in dairy and processing. Alistair.
And this is the wrong talk.
Could I just remind you, if you're asking questions, to introduce yourself and who you work for before you ask a question. Thank you. So, from Matt's talk, do I take it that we can actually get a flock of sheep, and from that we can have a couple of sheep that are our pharmaceutical sheep, from which we get the milk which is going to help us? Thought. Thank you, Alistair.
Right. So this is slightly more on topic, although the previous talk would actually follow on quite well from the last one. Okay, so what I'm briefly going to talk about is a couple of projects that we ran last year at Massey. I got involved in sheep milk only sort of about this time last year, perhaps it was February, when Craig was interested in setting up the first symposium, and he asked for some help from the food technology department to see if we could provide something. And that sparked my interest, and I set up a couple of fourth year projects. So these are honours year projects. And we press the button. Okay. So I ran a couple of projects last year. One of them was on processing, and that was around milk variability, which we've heard a lot about just recently, and the impact that has on rennet gel formation, which is one of the key steps in cheese manufacture. And that project was handled by Zhao Ping. She was one of our students who came over from Singapore. We have a close relationship with Singapore, and the students come over here to do some projects. And the second project was a product development one, and that was with Grace. And that one was focused on thinking, what else can we do in the cheese space? We've got a lot of cheeses in New Zealand. Sheep milk is making a lot of specialised cheeses. Can we broaden the market and go somewhere else? And so we looked at making a paneer. Okay, so the very first one, we've heard a lot about variation in sheep milk. We'll just go. As we can see, there's a little bit of variation in things there, according to this literature that we found. So we went off and collected some milk from Kingsmead, and while the total solids in the literature was talking about 16 to 20%, the milk we collected was actually 30%. But this was end of season milk, so understandably a little bit higher, but that was quite significantly higher. And when we looked at that, we were wondering what impact, we're seeing we make a lot of cheese in New Zealand, what impact is total solids having on our cheese manufacturing? Okay, so very, very simple sort of cheese process we've got here. You take milk, we'll forget about adding bacteria and things at the moment, but you essentially add some rennet. Those casein micelles that were talked about in the last one, they're normally stabilised from each other. I'll use my hands, jazz hands. So a casein micelle, it's got some hairy bits sticking out, and micelles will repel each other, so they stay stable in milk. You add an enzyme, rennet, it comes along and it cuts off that hairy layer, and the casein micelles can fuse together to form a three-dimensional gel, and that's what we then cut up to form cheese. Okay, so, and after that we cook it, the gel becomes compresses, and then you press it and form a cheese. So we've got two graphs down the bottom here. One's 10% solids, one's 25% total solids, and I've added rennet, and then we're following how strong the gel is with time. So both of these total solids, they're kind of in the range of what one might expect. After 5,000 seconds, which is a long time, but the 25%, hang on, I think I've got those back to front, but they're swapped around. So the 25% one will have a value of just under 1,200, and the 10% total solids will have a value of around about 28 pascals. So that's a huge couple of orders of magnitude difference in gel strength. And you'll also notice that the time to actually form a gel at the bottom, where it's running at 0, is much shorter in the 25% total solids. So there, I mislabeled those. Okay, why do we care? Why do we care about how long it takes for our gel strength to form? Well, if you cut too early, you're going to generate a lot of fines, and those fines are going to be lost from your cheese system, and they're going to end up in your whey stream, which, as we talk about a little bit later, the whey ends up typically in New Zealand as fertiliser or as pig feed, which is not a great thing because you're paying money for that. If you delay your cutting of your rennet gel, then you get reduced porosity, and you can have sort of higher moisture cheese. It gets harder to remove the moisture. If you have high moisture cheese, your shelf life is going to be decreased because bacteria can grow more easily. One of the reasons cheese is stable is because it's been salted, and you've got a salt to water ratio which stops and inhibits bacteria from growing, bad bacteria. So you're going to have also texture problems. So we want to have an optimum. So how critical is it, and how do we get there? Okay, so to cut a long story short, Zhao Ping spent a long time in the lab. She followed gel formation with milks from 10% solids all the way through to 30% solids. And then she modelled, generated one of those curves that we saw earlier. They're backwards, those ones. Oh. Anyway, the ones that we saw earlier, and then from those, using some mathematical modelling techniques, generated this overall equation down the bottom, which Craig informed me is going to be part of the quiz over dinner. So you may want to memorise that and know how to integrate it and differentiate it. Okay, so from that we generated a computer model now where you can go along on the day of making the cheese, and you can measure the total solids of your milk, put it into the computer model, press the go button, and it will tell you how long it takes until the gel has reached a particular gel strength, which means you know exactly when to cut it. So the example on the top right-hand side, we've got, depending on what gel strength you want, so something like 20 Pascal seconds or 24 Pascals, depending on the total solids, from 30% to 10% solids, you can see there's a 33-minute time difference between reaching, between reaching cutting time. So if you're out by 5 minutes or 10 minutes, that can actually make a big difference to your gel strength, and that can then have a big impact on quality. So if you can actually have it exact, set your alarm and get your alarm go off, and then commence cutting, there's an opportunity for optimising the cheese process. Okay, model limitations. This is a model system. We did use milk powder, which we bought from Blue River, so thanks to Blue River. So we're manufacturing a cheese from a powder, which will be different from a fresh milk. We had a temperature of 30 degrees Celsius. We didn't vary the rennet to casein ratio, so if you have a different rennet ratio, that will affect your curve. A different temperature, that will affect your curve. And our pH was in the range of 6.39 to 4.9. Again, if you have a lower pH, things are going to happen faster. Rennet acts faster at lower pHs. But we did generate a tool. We found that it was useful. Our predictions over the range that is useful for typical cheese cutting was sort of plus or minus about 5% at the greatest error, but it was much less for most of it. So we believe that it's actually not a bad thing to do. We can expand the model in the future, perhaps to include pH and different rennet ratios, something to do. So it enables accurate prediction of cheese cutting. We can minimise fines losses, avoid out-of-spec moisture, which affects shelf life and then texture. So that was the first project. The second project that we looked at was wondering what else can we do in the cheese space. So this is the one that Grace was doing. And what we developed was we decided that there's a whole space in the Indian sauces that are out there. So I like the Patak sauces. We have that a lot at home. It's quite easy. And that's actually, if you've been watching the shelf space in New Zealand supermarkets, that's been increasing year on year. It's getting larger and larger. And there's new varieties coming in. And I think Heinz Watties are also manufacturing them now, and they weren't in the past. So that tells you there's a trend happening. And the gap in the market there is that everything requires chicken or beef typically. And yet, when you go to a typical Indian restaurant, a lot of the time they have paneer as an option. So the vegetarian option is missing. And no one really is in that market. If you go to places like Davis Trading, you can, and I think there's a place in Petone, you can buy some paneer cheeses, but there's nothing that's widely available. So we looked at, could we move into the space? So Grace did some marketing surveys and found that people were willing to pay about $4.50 to $5 per 100 grams. So that works out, if you have 200 grams in a meal, you're paying $10 for a typical family meal, which is what you pay for if you're buying, some chicken breasts to cut up to put into your butter chicken or something like that. So if we market it on that sort of framework, then that's the sort of prices you would be likely get. We estimated the market size based on shelf space in a variety of supermarkets, and then translated that into a population who buy these ready sauces, then who buy the Indian sauces, and then we also set an income threshold limit based on demographics. So we said people above a certain income are likely to buy this. And we estimated about 31,000 units could be sold. The fresh milk that was supplied for this work was from Kingsmead. So we thanks to them for that. And Grace collected some of it. She presented some of this stuff at the the field days up in Hamilton at Mystery Creek, and we also had some last year at the Sheep Symposium, which was over at Massey, or Ag Research, I should say. On the processing side, Grace just didn't look at consumer development and marketing, but did processing. So the yield was 22%, which is about average really for any cheese. We had some losses into the whey stream, and she found that by optimising the pH, she could minimise fines. And it was also, when you go to press, she optimised the pressing conditions as well. And we decided that for a product like this, we probably need in-pack heating, and as long as we didn't exceed 30 minutes at 100 degrees, the product was quite nice. Once you got longer than that or at a higher temperature, we ended up with quite sort of, the product began to noticeably brown and become less desirable. So losses from paneer, we've got those down there, but that is quite interesting because we were losing all these losses. They had all these whey losses. So then we were thinking about there's a lot of whey losses here. And if you look in the literature, this is some data from other sheep cheeses, a variety of them there, and the yields are all roughly about the same, around that 20%. So for every 100 kilos of cheese you make, there's 400 kilos of whey, which is going somewhere. And that somewhere at the moment is mostly, I think, fertiliser or pig feed. So at this point, if anyone, any farmers or that are interested in supplying us with some whey, we're quite keen to collect whey from multiple sources to, particularly if you've got a unique breed of sheep or something like that, just to put into the mix, or you make an interesting cheese with every cheese is going to have different bacteria. Those bacteria are going to cut up the protein in different ways, and you'll lose some of that protein that you've cut up into the whey. That's going to affect the functional properties of that. So we're interested in making a really large database for the sort of public good here. Okay, so any different cheese making processes, anything we're interested in. Objective number 2, we're going to characterise these whey streams. So obviously we'll have composition, but then we're interested in things specific for making a food product. So if you're making a food product, number 1, it has to be safe. You don't want to kill people. That's not good for the industry. So you have to have some sort of heat treatment typically. So pasteurisation, UHT, retorting maybe. So how stable is the whey from a different process? If we bottled it, heat treated it, and you end up with lumpy, gooey stuff down the bottom, not so appealing, how can we avoid that if that happens? So we want to understand heat stability. The pH, different cheeses are going to be made at different pHs, we know this. How does pH affect things like sensory, things like foaming stability? If you have a very foamy product, is that good? Is that bad? Is that useful for making smoothies, perhaps, where you want a bit of foam and a bit of body in the product? And also things like gelation. So if you're processing, is it going to affect, if you have a heat exchanger and you're having fouling, your protein's denaturing in the heat exchanger, you're going to have decreased run times, which means more CIPs, and therefore you're going to have increased costs. So we need to understand those functional properties. Okay, expected publications. We should have a review on all of that data, compositional data, and also the functional properties of the whey. So I've thrown in now emulsification in there. And I think it would be nice to have a mathematical model where we can actually, if someone comes along and says, I've got this type of sheep, I'm making this type of cheese, this is the pH, what sort of beverage should I make that I could possibly sell down at the Saturday market if that's what you want to do? We could say, whatever you do, don't heat treat it. This one, make this kind of product instead. A different time of the season, a different type of cheese. Yeah, heat treat it, make something which you can actually send up to Auckland, because you need that extra shelf life to get there. So that's, hopefully we can generate that sort of information. Various commercial opportunities, maybe I should add vodka in there. But so we can have functional waters. I don't know if anyone remembers Fonterra brought out a product called Whole Water. It was a number of years ago. It was WHO with a 2 and then LE. That's how they kind of had a little pun in there. So that just had a very small amount of whey protein in there. So I think it was only around about, it was less than 1%, 0.5% or something. So you could take our whey streams, dilute it by about almost tenfold, bottle it, and then sell it at $4 to $5 a bottle. That might be a useful thing to do. One more minute. Yep. And otherwise, there's fermented products we can look at. So we've already got bacteria in there. If you ferment them, you can generate things like ACE peptides, as we heard in the previous talk. And maybe we can make some protein drinks as well. And so, thank you to, again, students and Mahika, who's just beginning, but I can thank her in advance for all the work she'll put in. Abby and Lee and Linda from Ag Research, and then also our industry sponsors down the bottom there. So, any questions? Oh, that is the last slide.
Do we have any questions? All good. Alistair, thank you very much indeed. Thank you.
Okay.
So our next speaker grew up on a lifestyle block with 40 sheep, and he then did his chemical engineering degree. So Jolyn is a PhD student at Massey University, looking at freezing sheep's milk. After you, Jeremy.
Thank you. I'll just try to get this thing going. So, there we go. So, yeah, I'm Joel Morell, and I'm a PhD student at Massey University, and I'm working on pellet freezing of sheep's milk as a transport and storage option. So I'm working on this with a postdoc, George Rittberger, and academic staff at Massey University, Richard Archer and Jason Hindmarsh. So, sorry, the clicker's been, there we go. There's a bit of a delay there, is there? So here we go. So the sheep milk industry is expected to grow rapidly over the next 20 years, as I mean, obviously look at everyone here. And this might cause some issues because a lot of these farms will be spread widely and fairly far away from processors, and a lot of these farms might be also quite small scale. So this means it becomes quite, and this also causes an issue because the sheep dairy industry doesn't have the same infrastructure to collect and process the milk that the cow dairy industry currently has. So what this means is that it makes storage and aggregation of the milk important. So if you've got a small farm, you may want to be able to collect several milkings together before the processor comes and picks it up, so that it becomes worthwhile for the processor to come pick up. So the question is, how do we store milk on a farm for a long period, so several days or maybe even longer? And the answer to that is freezing. So a lot of people already do it on some farms. However, they freeze it as a bulk by putting it in large containers, and this is a very slow process. So we're looking at, are there ways to improve this process? So when you freeze milk in a container, it is a very slow freezing process, and that has a few issues. So, for example, you end up with a phenomenon known as freeze concentration. Because the ice that forms is pure water, what ends up happening is that the freezing ice removes water from the milk, and that concentrates the remaining milk. And once this concentration becomes high enough, you end up affecting the stability of the caseins and the other proteins in the milk. So, another issue there is that when you freeze milk very slowly, you end up with some very large ice crystals growing. And this can damage the fat globule membranes and damage the fat globules, leading them to break up. And this means that your emulsion of the milk fat globules in the water can become less stable when you thaw it. And also that oxidation can occur, which leads to some rancid flavours. None of this is too bad if you're planning on making yogurt and cheese, because you're going to be changing the structure of the milk greatly anyway. But if you want to use this milk for fresh milk products or milk powder, then you ideally want your milk to be as close to the original as possible. So, another issue with freezing it in large containers and large bags is that it requires a lot of manual labour in order to fill up these bags and containers, put it in a chiller, and you have to have a chiller that's big enough to fit the bags and also for people to come in and out and pick them up and place them in there. So, our idea to improve this is to freeze the milk as a bulk, is to freeze the milk as a hail. So that's freezing milk in droplets between 2 and 3 millimetres in diameter. So what this is going to do is it's going to lead the milk to be frozen extremely rapidly. So whereas it might take you up hours or even days to freeze the milk if you have a big container of it, if you freeze it as a 2 millimetre or 3 millimetre droplet, it can take only 30 to 60 seconds to freeze the milk. This means that you have smaller ice crystals and there's damage to the milk structure. It'll fall very rapidly. It'll fall rapidly when you want to process it again later. And you also have benefits on the handling side and the processing side. So the processing, with our machine, our aim is to be basically continual processing. So your milk comes out, it'll go into a small storage vat, and it'll be frozen continuously. You don't need to store it or bag it and then have someone going in and out to a chiller, putting the bags of milk in there. You also have lower labour requirements for that reason. It should also hopefully maintain the stability of the milk when you thaw it again, and it will also make the storage and handling very easy because you can use methods that are already used to handle powders, bins and hoppers and such. So We recently got a sample of sheep's milk that was given to us on short notice, so we had to work out something to do with it. So this gave us a good opportunity to show what happens when you freeze it as a bulk and compare that to when you freeze it as a hale. So as you can see with this milk here that's been frozen in a half-litre container, it's taken on some banding with some darker and lighter areas, and this is indicative of the freeze concentration and migration of the fat globules and such inside the milk. And as you can also see from the top view, you can see some large ice crystals and a bit of a peak that's formed. So this will also fall very slowly, and that gives you more time for migration of components to occur and degradation of the milk quality. However, we also managed to freeze some milk as a hale by immersing it in liquid nitrogen. And as you can see, it's formed some nice small 2 to 3 millimeter spheres that have been frozen. It's still got a very nice white colour rather than that yellowish colour that you could see with the bulk, the milk that's frozen as a bulk. And also when we want to thaw it, it'll be able to be done very rapidly. However, liquid nitrogen, what we used, is great for in a lab, but not so much on a farm. It's expensive, fairly. It is fairly dangerous, and you have to wear equipment, safety equipment and stuff. And it also takes about 2 kilograms of liquid nitrogen to freeze every kilogram of milk. So it's not really something that can be rolled out on a large scale. So our aim is to develop a piece of on-farm equipment which will be able to continuously freeze milk as a small hale. So being on-farm, this piece of equipment will have to be inexpensive to buy and maintain. It'll have to be robust. It'll have to be reliable. Obviously, you don't want it breaking down every time you're milking. It has to be fairly compact, so it doesn't take up too much space in your milking shed or outside if you're putting say, a lean-to to cover it. And it has to be easy to clean, and it has to be easy to maintain. So we've started a project with me as a PhD student and our postdoc, George, and at the current, we've got a 3-year plan leading to the end product. So in the first year, we're aiming to develop a bench scale prototype to validate our ideas. And then by the end of this year, we aim to be building a 100 litre per hour scale. I will be investigating myself, doing more work on the physics that are occurring within the freezing milk droplet. So I'll be investigating the freezing profiles, and I'll also be beginning to investigate the effects on the quality, what happens when you freeze it and then thaw it as a small droplet as opposed to as a bulk. In the second year, we aim to be operating our 100 litre per hour scale prototype, and then be designing and beginning to build a on-farm prototype that will be put out on a farm, and we can test that. So at the end of that year, that should be out on a farm. We'll be beginning to test it. I myself will be involved in doing some in-depth modelling of the freezing process and the kinetics and transport that's occurring during that. And I'll also investigate what happens when you store milk over a fairly long period of time in droplets and frozen droplets versus as a bulk, and see how that affects the quality of the milk and what it can be used for after when you thaw it again. And in the third year, our final year, we'll be testing our on-farm prototype and evaluating how that's operating, seeking refinements that need to be made. We'll also begin seeking for partners for commercial manufacturing and rollout of this technology. And by that period, I aim to have an in-depth understanding of the phenomena that occur when you're freezing droplets, the phenomena that occur when those frozen droplets are being stored over some time and when they're thawed again, and how all of this will affect the properties of the milk and what it can be used for in future. And so this is basically just an illustration of our 3 to 3 year plan with it going along a little bit further. It says 4 years because there was a little bit of scoping occurring last year. So that effectively was my talk, and I'm open to any questions. Thank you very much for listening.
Any questions? Right at the back. Who are you, sir, and who do you work for?
Okay. Well, that's something we're going to have to begin discussions with MPI to see what their opinions are on that, and also see what sort of guidelines they'll have. I mean, as you said, this is a fairly undiscovered, unexplored area, so it's something we're going to have to look out for going ahead. Yes.
I'm just interested, are you going to compare a pasteurisation step or a thermophilic treatment step prior to freezing?
Well, the initial idea was that we'd be doing this before with raw milk, so that, for example, if you are just starting a sheep's milk, operation somewhere, and you want to be able to supply a supplier that's, say maybe a couple of hundred kilometres away, but you don't have the volume to be able to send a, warranted truck every day or something like that. Yeah. So the idea is that we want to be able to, basically freeze that milk as it comes out, so they don't have to put a, heat treatment equipment there on farm as well. So we want to sort of, limit the capital cost that this will involve.
So the answer is no, it will just be straight raw milk.
Yeah. So that's
One more question? No? Geraldine, thank you very much indeed. Stuart Gordon has been in the dairy industry for 20 odd years as a dairy farmer, and then as Chief Executive Officer of LIC for 6 years, and now Stuart works for Food Waikato. And Stuart is going to give his talk.
And joined by my colleague Dave Shute, who's been in the dairy industry for over 30 years, who's our operations manager. Okay, quickly the topics we're going to cover really is about the Food Innovation Network, its role in the food and beverage industry in New Zealand, background of Food Innovation Waikato and the actual food business, what we do, what our capabilities are, how we operate, our current client base, particularly around sheep milk processing, Dave will cover, and our future outlook. So I've really wanted to push that we're part of the Food Innovation Network, operating around 4 hubs. Food Bowl up in Auckland, Manukau City, strengths around fast-moving consumer goods, plant there for you to trial with, and also business development managers are able to help you assist you to take actual food to market, understanding labelling requirements, who to contact, who to work with, how to get funding, all that sort of thing. And that's replicated right with Food Waikato, Food South and Food Pilot in respect to those business development managers. But each one of these hubs has their own special equipment. Obviously, we'll cover Food Waikato, but Food Pilot specifically is our research and development arm. Down here at Massey University, we use that to undertake our research, or we put clients that come to us looking for research in contact with them. And Food South has, again, in the fast-moving consumer goods, all helps you to take produce to market, all sponsored by Callaghan Innovation. Just some background to Food Waikato. So some smiley faces up there, I think, is that the speaker or something like that? July 2011, we commissioned in 2012. Our funding really all came from, base funding came from government, just about $4 million, and the rest Waikato Innovation Park put in over $8 million. We had one key founding client, that was the Dairy Goat Cooperative, and I suppose this typifies the role we play in the industry. Here we are, they had some major choices to make. They had markets to develop, and we've heard Scotty talk about their philosophy. Until they had markets, they weren't going to develop supply, and the same if they don't have markets, they weren't going to build their spray dryer, which cost them $70 million post their participation with us. So we worked through them as a cornerstone client, 120 days for 3 years. That allowed them to make that investment, allowed them to build their markets and build in supply. And so that's what our role in the industry is, and that's why we see the sheep industry as a key target for us, helping both supply and markets to build. Ownership, you see here, is 70% by Hamilton City Council, holding it in trust, and 30% by Callaghan Innovation. So what are we? We're definitely open access. It's your product. You supply the raw materials generally. We're like a motel. You book us, you can book us for half a day, you can book us for a whole day, and we have a rate. We operate 24/7, 365 days a year. I think this year's operation we'll do about 280 days, I think, somewhere around there, Dave. In total production, add on the other maintenance days, etc. So we're full. So we charge you a daily rate, and then based on how long you use, we then charge you a variable rate around power, gas, chemicals, etc. So depending on the product, it can range from $2,500 a tonne to produce through our thing up to $8,000 a tonne, depending if you're booked it for the whole day, producing, say, 8 tonnes for the day, or you've booked it with a type of product that may only produce 1 tonne for the day. But that's the sort of range you can get. And with that, I'll hand you over to you, Dave.
Thanks, Stuart. Okay, this slide outlines our capability. As a previous slide showed, we built the plant for $12 million. Initially, it was a fairly tight budget. We had to get it built for that. So quite a few hard decisions were made around what equipment we'd have. So the stage 1 development, we put in milk reception, pasteurisation, evaporation, spray drying, packing. So whatever turned up in the tanker basically ended up in the bag minus the water. So quite limited in the range of products we could make. The only thing what really differentiated the products we made was if it was goat milk, sheep milk, organic, halal, kosher, and the like. We had no way of modifying that milk at all. Dairy goat underwrote us for the first 2 years of our operation, and most of our manufacturing was for them. When they departed, we realised it might be a hard row to hoe to fill a plant, so we invested a further $6 million and put a wet mix plant in. So that wet mix plant now, we can take raw milk, we can take the milk in, we can separate it, standardise the milk, and the wet mix plant allows us to do fully batch product. So that means we can take macro ingredients, micro ingredients, we can make fully formulated infant formula to the can if required. We've got a number of certifications in place that allow us to operate. So we're quite unique in the range of certifications we've got. Most dairy plants are dairy only. We have a dairy RMP, but we also have a non-dairy animal products RMP, which is actually giving us a few challenges at the moment, getting that through MPI, but that's the way we need to go because we actually make some micro encapsulated fish oil products, which don't fall under the dairy RMP. We also have a food safety certificate, so that allows us to make other products outside the RMP. So in the past we've made powders like avocado powder, which creates challenges in terms of changeover between that and dairy products, but that's what we've done in the past. Going forward, highly unlikely we'll be doing those sort of powders. We've got approval, but for any new fruit or vegetable powders we have to apply to MPI and get that across the line before we actually do the work. We have halal certification, we have kosher certification, and we're also organically certified. Okay, which button is it? Right, in terms of sheep milk.
This one.
Right. Our client base for this season, we have 5 fresh milk contracts in place. So 3 goat companies. So the original dairy goat have gone back, they built their second dryer, they're no longer with us, but now we've got really the second wave of people coming through. So New Image take a day a week with us, as do CDG, which is the Central Dairy Goat Company, and NGC, the Nutritional Goat Company of New Zealand, take about 2/3 of a day. So 2 2/3 days per week we're doing fresh goat. And then we have the 2 sheep companies, which are both represented here and presenting. So dairy, Spring Dairy and Maui, they are taking up about half a day at the moment. Outside that, so that takes about 3.5 days a week, and the other 3.5 days a week we have a range of other clients will come in and fill the plant. So we can make nutritional powders, so we do infant formula, follow-on and growing up formulas, mainly goat powders. And then we do the microencapsulated omega oils from either a fish, algal or fungal source. We have done colostrum in the past, and we've got a project on the go with Ag Research doing ultra low heat IG powders. And the other days what are still available, we do some 1-day development trials. Stuart said we do about 280, I think it's going to be a bit higher than that, around 320 days in the current year. So we're also 90% booked for the following season. In terms of the sheep processing, with our fresh milk contracts, because we've got 5 different fresh milk suppliers and the logistics around juggling those throughout the plant, we just process the milk once a week. So to be able to do that, it's quite outside the norm. I did like 25 years in the bovine industry working for Fonterra. If your milk was more than 2 days old with them, it was severely frowned upon. So we had to do a lot of validation work before we could extend out and hold milk for longer periods than that. So we used some milk, I think it was from Kingsmead and through Massey, and there was a lot of trialling done in terms of how long we could hold that milk before it deteriorated microbially. So there was a lot of heat treating it at day 1, day 2, day 3, and extrapolating that out. And we've actually found you can hold milk up to 10 days, as long as you hold it for under 2 degrees and heat treat it at the right time, you can go out for a sustained period. So at the moment, as I said, we hold milk and process it just once a week. In terms of transportation, that sort of helps. Like going forward, we would like, if people were doing it, we'd prefer they actually heat treated it on the farm, and we picked it up off the farm every 7th day. It just makes it logistically easier for the factory. Silo management, with the 5 different suppliers. At times we have 5 different suppliers of milk on site at once, so that can be difficult. We process mainly into whole milk powder, both standardised and unstandardised, but we have moved into skim milk powder. So we've been, over the last 6 weeks, we've been skimming the milk for one of the clients, which means we end up with residual cream. It's absolutely beautiful. It's the whitest cream you'd ever see coming off the sheep milk. That gets shipped off site and goes to another third-party processor who is freezing it and putting it into storage. We haven't had any real quality issues with the powder we've produced, and the yield has been excellent at 95% plus. On the whole, issues have been minimal. There's been a bit of talk in the presentations about total solids. From experience, we've seen the total solids sort of start at the beginning of the season around 16%, and they've worked their way up at the moment. Tomorrow we're doing our last day of spring for the season, and the milk's up around 20% solids. Our equipment is only designed to process milk. It's actually designed for goat primarily, and goat milk's typically 11.5%. So we actually water the milk down to process it. So we actually put water in to take it back out, but because of the way the evaporator and dryer are designed, that's what we have to do. future outlook for next season, as I say, we're fairly well full. Most of our suppliers are looking to grow their supply by around 20-25%. So we're in a bit of a catch-22 situation, growing these businesses, but we've got no room for them. So we're actually trying to squeeze some clients out at the moment. We've got a saying that if our clients are successful, they're going to leave, and if they're not successful, they're going to leave. So that's the guts of it. We're building up a lot of infant formula compositional data, because we see it next season we'll probably move into sheep milk formula. Following year, especially in terms of the sheep, there's going to be a large step change in terms of the volume coming through. We see ourselves doing probably 2 days a week of sheep milk during that period. The dilemma around being so full brings into, I guess, view whether we need to put a second dryer in. It's pretty hard at the moment. We have a business development manager. Most of the phone calls he takes, he's telling people bad news, or he looks for an alternative. He works really hard with the clients, but he tries to find them alternative drying, but unfortunately we can't accommodate them at the moment. So we're looking for professional potential partners. In terms of a second dryer, we've got one client who's pushing us hard. They want to invest 50% of the sum to build the second dryer. So we're looking for probably 2 or 3 other partners to fill the other 50%. And with that, there's a real opportunity to put some capability in place. We've got a small laboratory at the moment, but we're looking to maybe expand into other laboratories. We've got ag research on the site in Waikato downsizing, so there's an opportunity to take some of those people across and some of that dairy expertise onto our site. A few lessons we've learnt along the way. Some of these have been hammered a bit today, especially the market first one. That's what we'd say to anyone. We get phone calls from people who have actually developed their farm, built sheds, just about ready to milk, and they've got nowhere to send the milk to. It's almost build it and they will come sort of philosophy. Yeah, you need to have that market and know what you're going to do with milk and where it's going to go before you actually do the first bit. Yeah, that's the second point as well. You actually need an outlet for the milk before you start breeding. A lot of the, especially the goat and the sheep stuff we're doing at the moment is just whole milk. The prices are excellent, but that probably won't be the case forever. So you actually do need to look at moving into value-added products further up that chain rather than just dwelling at the bottom. Those prices will run out sooner or later. And lastly, there's many elements to a successful business. There's a lot of on-farm people here, but you need the on-farm transportation, the manufacturing, the compliance work, the export documentation side of it, and the market side of it. Most of the people who come to us are good at 1, maybe 2 of those elements, but very rarely are they good at all of it. Unfortunately, we really stress to our clients that at the end of the day, it's their company, that's their responsibility. We'll help them as much as we possibly can, but at the end of the day, we really look after the manufacturing and not the rest of it. Okay, that's us. Any questions?
Any questions?
Meat farming, amongst a few other things. There was, I think, 3 times the price increase if we're just thinking about milk. You started at about $2.5 grand a tonne, and then it shot up to $8 grand a tonne, which is almost 3 times the cost. Yep. If we're just talking about milk, can you just explain that difference?
A lot of that's around the day rate. So we've got a half-day rate and a full-day rate. So most people want to maximise, if they take a day, they want to maximise that day. So, yeah, sure. Our day rate is typically 10 grand a day. So if we can make, the dryer, I forgot to mention, is half tonne an hour. So if you run a full day, you're going to get about 9 tonne of whole milk. So you multiply that out, plus your variable rate going in. If you maximise the plant on a whole milk powder, you'll end up paying about 2.5 grand a tonne. But then we've got other clients who'll come in, it'll be a slower product through the plant, higher development, they might use less hours, they might only make 2 or 3 tonne a day, but they're going to get charged the whole day still. So when you recalculate it back out, it's going to be $8,000. So we emphasise to our players, we get a lot of people, obviously Fonterra's under a degree of pressure at the moment, they want to leave Fonterra, they want to move across to us, and they're saying, oh, can you process my bovine milk for me? And like at $2,500 a tonne? Like, of course we can't. Like, we basically say if you're not selling your product for $10,000, it's not worth doing at our plant. We're only a boutique plant, we're half tonne an hour. We're too small for that sort of work.
One more question?
What happens to the water? What do you do with it?
The wastewater, yeah, we're actually within the Hamilton City Council boundaries. So we're one of the big 6. There's the highest effluent volume discharges. So we're the 3rd highest effluent discharger within the city boundary. So we've got an effluent tank, which just goes into a 6-inch main, which goes to the municipal plant.
Very lucky.
That said, it's fairly clean effluent, like half it's cow water coming off the evaporator, which is basically distilled water.
Jeff, what do you pay to discharge it away, or you don't say exactly, but is it a big cost? Usually it's a big cost to discharge into the sewer system.
Yeah, we pay about $40,000 every 3 months. So I don't know what the per litre rate is. We charge about discharge about 200,000 litres a day. So if you can do the maths.
Thank you very much indeed, gentlemen. There are 2 to go. So Richard Archer has 20 years in the dairy industry. He's now a professor in food engineering at Massey University. Richard.
I'm also going to talk a bit about spray drying of sheep milk and following on from the guys. Jazz Hewison, right at the beginning of the day, I think he said scale, 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 cooperation, cooperation. That was my count anyway. Industries, companies need to get to scale. Cooperation is one way to do it. We heard about Blue River, went to scale quite early. Good way to make big money to start with, or lose big money, and when you're doing something really new, it's quite hard to do everything right the first time. We've heard a bit from Scotty Chapman about Landcorp. They've also got deep pockets and a route to go to scale, but they're being very careful about doing it. Everybody really is going to need to go to scale. The industry's not going to be just these big players, it's going to be small players. And we heard from Jolan one way of that by which small producers, sheep milk producers, can generate scale through clever freezing. So my pretty simple message was that cooperation one that Jazz said right at the very beginning. Now there are several, and I'm talking really about cooperation between industries. There are several industries requiring spray drying. The meat industry has blood and blood products, plasmas and the like. The meat industry also, from time to time, some players have hydrolysis. The fruit juice industry is out there. We've got goat milk and goat milk infant formula, we've got sheep milk and sheep milk infant formula, and possibly got honey. The non-Manuka honey may be looking for dried products, dried roots. So there are several industries out there which may be able to get together and share drying capacity one way or another. But there are lots of incompatibilities. Dave was talking about making avocado powder. If he tried that, if he applied for that again today, he probably wouldn't be allowed to, because the rules around infant formula have changed and may not be able to get in. They've proven they can do it well, but if you've got dairy, you can probably only do it with other dairy or with infant formula, dairy-based infant formula, and it's very difficult to have MPIs unlikely to allow you to do any other product through that same dryer. You can do meat with blood through the same dryer, but there's a possibility of a halal issue into there, because one's halal and one's haram, so that they don't necessarily go together. It depends on what markets you're chasing. You could possibly do meat with juice. No one's asked MPI that yet, so we haven't had the question. So there are incompatibilities on a single dryer. But you can put multiple dryers on a single site, and that's the Fonterra Hawera site, the Wharara Road site. There are 6 spray dryers on that site, all doing milk or whey, of course. But it's possible to put multiple dryers on a single site and share common services, staff, management, capability, engineering support, all the rest. Quite a lot of your money is in that area, not just in the dryer itself. So you can put several dryers doing this different products on the same site. Now I'm looking particularly at the Lower North Island here. So there's the Lower North Island with a very important place right in the middle. That I stole off the Ministry for Environment website, but fuzzy, all that lovely beige colour is high producing grass. There's quite a bit of that in the Lower North Island. This I stole from the beef and lamb site that shows the meatworks, quite a lot of meatworks around in this area. And if you have a look and stand back and squint your eyes, you can throw a couple of crescents through that. There's that's the kind of space which is generating all of these liquid materials. The juice tends to come from the east. The meat and milk products from all over. So there's clearly a central location that if you're going to take a truck and an hours a driver is allowed to have a truck, you can get to there from anywhere in a day and back. This I stole from Fonterra's website and then added a bit that shows some various dairy factories in the area, because I'm looking to see where the spray drying skills are located. There's also the open country plant at Wanganui, of course. So there's quite a lot of skills around in that area, which also says if you're drawing skills, you would put a central station plant there. So that's all it is. It's not even a plug. But if this industry is going to develop, it's going to need to find many different ways of gaining scale. If spray drying and powders is a big part of the sheep milk future, then sharing and getting together with other companies, so you're using other people's capital, that might be a way to go. Consider working together. Thank you.
Any questions for Richard? I have one, Richard. One of the speakers earlier on mentioned that we should be moving up the value chain. If we move up the value chain, we don't need a spray dryer. Thoughts?
Well, we heard from Dave that if it's less than $10,000 a tonne of product, and that spray dry product, then forget. I can go one up on him. We've got a spray dryer and it's only 25 kilograms an hour, and we do get commercial people manufacturing. So that's probably $100,000 a tonne product, and it's spray dried product. Spray drying can encapsulate all sorts of stuff. You can formulate it with it. You can put other value in. You can augment value. It's just a tool.
Thank you very much indeed. Our final speaker tonight is Gareth Young. Gareth has 5 years banking experience in the UK. He then went and worked for Elanco as their business manager for sheep and beef for 4 years, and he's now the senior rural consultant with us at Opus. Over to you, Gareth.
Thanks, Mark. Thank you very much to Mark for that introduction, and also to the other speakers today. It's been a really informative day. I hope you've all found it like that, and hopefully I can add something to that. I am completely aware that technically I have 10 minutes before I'm holding you back from getting to the bar, so I'll go as fast as I can and try and be as thorough as I can. So I am here today to discuss the Greater Wellington Regional Council case study on sheep milking as an alternative land use under irrigation. So through this irrigation, through this presentation rather, there'll be a background of what the Wairarapa Water Use Project is, a brief introduction and outline of what was entailed in this RFP, run you through the farm systems that were designed, the financial analysis around the capital infrastructure, the capital input, as well as some seasonal budgets and some sensitivity analysis. The management changes required by people who are considering converting from arable dry stock farming to, as Jazz described in one of the first speakers of the day, a dairy system. Finally, thanks to Lucy as well for helping out with the market connections and the industry support, outlining what is there at present, what can people expect if they were to join this industry. The Wairarapa Water Use Project is investigating a multi-purpose water scheme for Wairarapa to collect and store water, then distribute it for a variety of economic and community uses. What they're looking at the moment, and they're doing geotechnical testing as we speak, on 2 potential dam sites to supply 30,000 hectares of land in the Wairarapa, which is currently high producing but inclemently summer dry, and how they can add reliable water to that. The aim is to do it in a way that promotes sustainable management of land and also increases economic benefits to the region. And last night, just as an aside point, on the internet it was noted that they were also the recipients of further funding from the Irrigation Acceleration Fund, so it's looking good for them. The project brief, and just as an aside, there's no date on this. There's been no specifics as to when this conversion will take place. It's a year 0 to year 5 scenario. And it's designed as a reference document for people who are thinking about sheep milking, and there are a number of other land uses in the project as well. So it's a starting point for them, really. To develop detailed land use conversions for their component, or our component, in this case it was sheep milking, on 2 case study farms, and there were there's actually 3 case study farms in the project. 2 were selected for sheep milking, and it's not looking at the current farms or the farming systems. It's the 3 farms were identified to be a template for farmers who are considering land use change, to be able to look at the farm, look at the soil types, look at the size, the scale and the topography, and say that's like mine, I'm going to go and see what they've done there, or those 2 are like mine, so can I get a comparison? The conversion plans were done through undertaking site visits, firstly to an existing sheep milking property, secondly to the 2 case study farms to be able to understand what was running there at the moment, what the owners thought about the potential of their properties under irrigation, and actually see how they run at present and what the systems could work like. This is stage 2 of a multi-stage investigation process for Greater Wellington Regional Council. The conversion plans address the capital costs, including the irrigation development costs, or the capital cost of irrigation, the future effective farm surplus calculations, and here I must say this excludes the cost of water because that has not yet been determined by Greater Wellington Regional Council, and then sensitivity analysis around key variables: milk price, expenditure, production. There were a number of assumptions and limitations in this project due to the scarcity of data, mainly around budget, and also there's constraints that were put in the RFP put out by Greater Wellington. Then we move on to the change in management and lifestyle, and finally the market connections and the industry support and what's available at present. So on the 2 properties, Easter Bow is the first one. It's 180 hectares effective, total at present, 175 hectares at present, and there'd be 97 hectares under 1 centre pivot irrigation, targeting running 2,000 ewes with the hoggets grazed out and no additional housing. The aim is to maximise the production under irrigation with the high metabolisable energy species such as lucerne, plantain and new rye clovers, with all male and surplus ewe lambs to be sold prior to Christmas, and these would be finished on a forage outside of the irrigation area, running herd sizes of about 5 to 700 and in 5 hectare paddocks. So you can see it there quite clearly, one nice big pivot, and there is still a reasonable amount of area outside the pivot. What appears to be the cultivated area, that is the lowland stony soils, so these dry off in the summer. So Otahau, the second farm that we looked at, slightly bigger at 336 hectares, with 100 hectares over the road, off the main block, which would be used as a runoff in this situation. So the milking platform would be 223 hectares, similar pasture species, with the replacements being run on the hill block or outside the irrigation area, because not all of the milking platform can be irrigated. In addition here, there would be ewe housing established here for a more intensive system. 3,000 ewes, and in the same mob sizes as previously on Easter Bow. Sorry. So you can see there on the map, there's guns and pivots, so this is a lot more complicated system. And there is also areas with heavier soils on this farm that don't warrant irrigation. And these maps have been done by Greater Wellington, and in the very early stages of the project, there were land assessments done by Land Vision of Wanganui to look at all of the soil types. So there's a lot of work going into this for people to look at. So moving on to the capital investment, start talking dollars. So Easter Bow, being a slightly smaller farm, no ewe housing, less capital cost. Otahau, conversely, more capital cost, ewe housing. What pushes the value of the conversion cost per ewe up on Easter Bow is actually the difference being it costs no more to build a shed for 3,000 ewes than it did for the 2,000 ewes in the information we got. So that pushes the conversion cost per ewe up. Although it's not a large, there's not a large difference there. So to give you an outline and a background on the income and the seasonal financials, a conservative approach to budgeting was taken, particularly around the production. Year one being 40 kilos milk solids per ewe, increasing through to 60 kilos of milk solids per ewe by year 5. Other contributing factors were an increase in lambing percentage from 150 to 170% through time, through improved management, potentially improved genetics. The 5-year budgeting price for milk did not change. However, there is a 2.5% year-on-year increase in costs for inflation. This is as per set out in the RFP. So there is a burn factor in there in the first year of negative $658 as an EFS per hectare, moving through to year 5 where it goes to close to 2,500. Otahau, once again the same approach, and the key area is looking at the EFS per hectare. No loss, no negative in year 1, and a slightly higher EFS in year 5. There are no return on investments or return on capital included in this project, as it was deemed to be too unrealistic without allowing for the cost of water. There have been numbers done, but I can't disclose them at this stage. So those are the numbers. So it does show that sheep milking under irrigation in the Wairarapa does seem to be a reasonably good idea. Looking at the management and the labour requirements, this was broken into 4 key areas. Pasture management, confirming what Jazz said, and it was what was told to us on one of our site visits. It's not a traditional sheep system. It is a dairy system. And therefore the animals have to be treated like that. The pasture has to be treated like that. So it's a lot more monitoring. There's a lot more attention to detail. The production under irrigation must be maximised to make this system work. I also have to say here, due to budget constraints by Greater Wellington and also time constraints for getting this report, This has not been tested through a feed budget, and that is something that I have offered to do for them, and I'm sure that that would throw up a whole bunch of different results as well. The stock management side, it's a dairy system. Feed the stock like you'd feed a dairy cow. If you want the milk, you've got to put stuff in, and high quality stuff. Good rotations, maximise intakes, and this will also have an effect on the animal health, because at the moment there are very few, if any, nil milk withholding animal health treatments. So you've got to look after your stock. People management, compared to your existing dry stock system, and looking at the two farms compared to their current systems, if they were to convert, they'd run a lot fewer staff than would be required under a sheep milking system. So this requires upskilling by the owners to be able to manage those issues that invariably do come with having more people. And the lifestyle changes really comes down to dry stock or cropping versus a dairy system. The farmers have to consider what is their tie to the land under their current system versus the new system. What are their business goals? What's their debt loading? What's their stage in life? And what is their risk appetite for, whether it be now, this year, 5 years' time, an industry that may still be evolving? Are they prepared to go into that, or would they much rather just sit back and carry on doing what they know? The market connections. Asia, we looked at powder and infant formula. USA was cheese. New Zealand, the local market, cheese, yogurt, ice cream. Australia, bulk frozen milk, cheese. Who is the target customer? What are we thinking about? Who are we trying to get to? We've heard from a number of people today who have talked about watching out for this industry, making sure we don't do a new industry, a boom and then a bust. But we need to make sure we're targeting the right customer and being consumer focused and consumer led. The bovine intolerant babies and adults, the health conscious, the people wanting the functional food benefits from sheep's milk versus bovine milk, the well educated who can see the benefits, can understand the benefits, and also the affluent, who, as Scotty said, I think it was Scotty that said, the people who are prepared to buy Lewis Road Creamery and not think twice about paying $2 more per litre. They're the people we want to buy the sheep milk that we produce. So moving on to the industry support. At the moment, there is no formal industry body. The industry development is coordinated through Massey, through Craig Pritchard, and Ag Research, both of who have done a fantastic job coordinating this conference. From what we gathered and what we found out, there's little interest from Dairy NZ and Beef and Lamb. And this might be because they don't know where sheep dairying fits, or maybe they've just got other things to worry about. There's a couple of fantastic templates out there in terms of in the USA and the UK. Could we look at fostering some of their developments and some of their movements? So in summary, sheep milking under irrigation in the Wairarapa under the parameters of the RFP and the project is a viable land use option. The EFSs were highlighted there. They are before the cost of water, as this is not known. There are changes required in both the key management areas of the farming system, and by the people who make these. There are markets available. We're seeing and hearing more and more stories of people who are able to break into markets, being consumer-led. And no industry body. Is this restricting the growth of the industry? Finally, the acknowledgements. I mentioned Lucy earlier on. She was responsible for the connections to the markets, the products, the barriers and improvements in the industry support services. So thank you, Lucy, and thank you for introducing me to this project. And also to Waitui Kuratau Trust, Peter Gatley, Jake Sharon and Garth. Thank you for your openness on the day we visited you. It was quite refreshing to hear how frank and open you were about the industry, where you think it's heading and what you think the potential is. So thank you very much, and that's me. And I'm only 5 minutes over time, so.
Thank you, Gareth. Do we have any questions for Gareth?
They want to get to the bar.
Go for it, Sean.
The overseer for this has been done by Ag Research. Natalie, wherever she is, or she may have left. Oh, there she is, right down the back. Natalie and Brian Deventer are doing it as we speak. And I'm not sure what the findings are at the moment, but it is being done, yes.
One more question? Yes.
After discussions with WKT, it was based at $15 a kilo milk solid, and went through. Peter took us through his methodology for that number, and it sounded sound to me. So that's what we used. There's a very, very long list of assumptions in the budgets, I have to say.
Brilliant. Thank you, Gareth.